Today, we're going to learn about chemical bonding and the difference between ionic bonds and covalent bonds. But before that, I want to show you or explain to you how it is possible for atoms and elements to bond. So here we have the periodic table of elements. Now, the big question is what makes bonding possible? And the answer to that is electrons. Okay, and to be more specific, we want to say valence electrons. Okay. Now, to define valence electrons, they are the electrons in the outermost layer. So electrons in the outermost orbit, orbit in an atom. Okay, so valence electrons are the electrons in the outermost orbit in an atom. So just in case you don't know what an orbit is, let's take a look at beryllium. So beryllium looks like this, right? And beryllium is actually in period 2. So again, rule of thumb, periods are rows. So consider them this way. A group is a column. So up and down, okay? So beryllium is in period 2. So this is period 1, period 2. So it's in row 2. So because it's in period 2, we know that beryllium has 2 orbits. So it has one orbit and it has another orbit. Oh, it's really bad. Okay, so beryllium has 2 orbits. Now, how do we know how many electrons fill these orbits? So because each atom has an atomic number, in this case, the atomic number of beryllium is 4, we know that beryllium has 4 electrons, okay? Now, how do we know where to place the electrons? Well, because we know that beryllium actually is in group 2 right here, so up and down in the column 2, we know that beryllium is going to have 2 valence electrons. So beryllium is going to have 2 valence electrons. And when we start valence electrons, we want to start from the right of beryllium and then go up counterclockwise. And so that's what beryllium valence electrons, or the outermost orbit, looks like. But where do the other 2 go? Well, the other 2 actually go inside. So they go here, following the same structure, starting from the right and going up. So this is what beryllium looks like. This is beryllium's orbital structure. Now, what we want to focus on is bonding, okay? So for bonding, all we need to see are valence electrons, because we cannot bond with the ones in the innermost orbit. Why is that? Because the ones that are more susceptible to bonding are the ones outside. And why is that? Because the ones on the inside are closer to the nucleus. And why does that matter? Well, if you think about it, what's the charge of a nucleus? Positive, right? And in the electrons, the charge of an electron is negative. So these electrons that are more closer to the nucleus are more attracted to the nucleus, because if you remember, if you've heard the saying before, opposites attract. So the electrons that are farthest away from the nucleus obviously have a less charge or a less pull to the nucleus, or a less inclination to close to beryllium or close to the nucleus. So it's very easy for them to kind of just leave and bond with other atoms or share themselves with other atoms. So that's what beryllium looks like, right? But again, we only need valence electrons. So what we want right now is we want to take beryllium, and all we want to do is we want to draw the valence electrons. So this is what it looks like. Now, this structure is called a Lewis structure. Now, to define a Lewis structure is basically the representation of valence electrons by using dots. So those dots represent the valence electrons, and that is the Lewis structure of beryllium. Okay, now let's take a look at some other elements. Okay, let's take a look at another example. We're going to take a look at carbon right here. Now, carbon is in group 14, so that means it has 4 valence electrons. Just take that 4 right there. We're going to draw the Lewis structure of carbon. So carbon is going to look something like this, carbon, right? And because it has 4 valence electrons, we're just going to start from the right and go up. So 1, 2, 3, 4. And it's as simple as that. That's the Lewis structure of carbon. Now let's take a look at oxygen. Oxygen has 6 valence electrons. So now let's take a look at what the Lewis structure of oxygen looks like. So we start here, 1, 2, 3, 4. So now we notice here we run into a little issue. It's symmetrical now, right? So what happens to the 5th and 6th electron? Well, we just continue the same pattern. So 5, 6. And that is what oxygen looks like. And if you notice now, there are pairs. And this is going to be very, very handy when we start doing bonding. When speaking of bonding, let's go ahead and start. There are two different types of bonds. There is an ionic bond and there's a covalent bond. We're going to start with an ionic bond. So ionic bonds is when you see a metal and a non-metal that are going to bond together. So when you see, let's say, calcium, which is a metal, let's take calcium, and let's also take oxygen, which is a non-metal. So when you see calcium and oxygen, you're going to say, oh, that's an ionic bond because calcium is a metal and oxygen is a non-metal. So what am I going to do to bond these two together? So it's kind of supposed to be drawn like this, CaO. So calcium oxide, or calcium and oxygen bond together. So I like to start by drawing the individual Lewis structures. So for calcium, if we take a look at the periodic table, we know that calcium is in group, let's identify where that is. Calcium is right here, and calcium is in group 2. So how many valence electrons is it going to have? It's going to have 2 valence electrons. So we're going to start right and go up. So that's the Lewis structure of calcium. Now, we already did the Lewis structure of oxygen. We know that oxygen has 6. Okay, so that's the Lewis structure of oxygen. So this is basically the 2 atoms that we are bonding together. Now, where do we go from here? How do we know how to bond these 2 atoms together? Well, here is a rule of thumb. You want to remember that metals are the ones that give to nonmetals. Okay, because nonmetals are very, very hungry. You want to remember that they are very hungry. And the only way you can fill them up is by allowing them to have 8 electrons. So usually what happens is that the metal gives whatever electrons they have to the nonmetal so that the nonmetal can be full. So for example, here we have 6 valence electrons, and here we have 2 valence electrons. And because calcium is a metal, calcium is going to give its 2 valence electrons to oxygen so that oxygen can be full. So what's going to happen is this one is going to move right here, and this valence electron is going to move right here. And so what happens is this is going to become calcium, and then we just have oxygen with its 8 valence electrons. So if we take a look at oxygen itself, we can see that oxygen is very satisfied because it's full and it has 8 valence electrons. It's very happy. So now we have completed our first ionic bond. Let's move on to covalent bonds. So covalent bonds happen between 2 nonmetals. So when you see 2 nonmetals, for example, NH3, we know that nitrogen, right, which is N, is a nonmetal, and we know that hydrogen especially is a nonmetal, right? So we know that whatever bond is going to happen between them is going to be a covalent bond. Now, what's the difference between ionic and covalent? Well, covalent bonds again are both have to do with nonmetals, and number 2, they actually share electrons, and they have to make sure, and you have to make sure that they all connect to each other. And we'll get to that in 1 second. So I like to first start by identifying how many valence electrons I'm working with. So I like to write it like this so that I have 1 nitrogen and 3 hydrogens. So I'm going to do the math. Okay, so I have 1 nitrogen, I have 3 hydrogens, and how many valence electrons are in a nitrogen? Well, if we take a look at our periodic table, we can see that nitrogen is right here, and it is in group 15, so it has 5 valence electrons. Nitrogen has 5 valence electrons, so that gives us a total of 5. Now, hydrogen has actually 1 valence electron. So that gives us a total of 3 valence electrons. And as a complete total, we have 8 valence electrons that we're working with. In essence, we have 1 nitrogen and we have 3 hydrogens. So we want to figure out now what is the best way to set up the Lewis structure. Do we set it up like this? Can we set it up like HNHH? Can we set it up as HHNH? Or do we set it up where nitrogen is here and it has equal access to each hydrogen? I think that that is the best way. Now, why is that? Because again, as I mentioned earlier, a very particular characteristic of a covalent bond is that they have to share electrons. And the best way possible is to have each hydrogen have access to nitrogen, or vice versa. The first step in bonding is making sure that each atom shares at least or a minimum of 2 electrons. So we start here from the right, 1, 2, 3, right? And then do 4, 5, 6. So now we just got rid of 6 electrons, and now we are only left with 2. Now you can ask yourself, okay, from here, what do I do? What's the second step? Where do I put the rest of the 2 electrons? The second step is to figure out if each atom is satisfied. And how do you know if it's satisfied? Well, for any atom except hydrogen has to have 8 electrons. And why except hydrogen? Because every other atom except hydrogen fulfills the octet rule, which is needing to have 8 electrons to be happy. Okay, but hydrogen actually has the duet rule, which only means that they are just really happy with 2 electrons, and that's how it is. So let's take a look at each atom here. I like to circle them. So this hydrogen is really satisfied because they have 2 atoms. So hydrogen is satisfied. They fill the duet rule. This hydrogen, satisfied. They have 2. Did I say 2 atoms? I mean 2 electrons, excuse me. 2 electrons. And this hydrogen is also satisfied because it has 2 electrons. But now let's take a look at a nitrogen. If we take a look at how many electrons nitrogen has, it actually has 2, 4, 6 electrons. So nitrogen really isn't happy. It's not satisfied because it actually wants 8 electrons. Well, luckily for us, we have 2 electrons left. So all we have to do is move those 2 electrons right there and add them there. Now this is a covalent bond. Nitrogen is happy, hydrogen is happy, and they're all very satisfied, okay? So that is the difference between ionic bonds and covalent bonds.